Good afternoon everyone. My name is Leela Kalyan. I am from CSE department. Today my topic is preparation and application of IR spectroscopy. Subject name is chemistry. Next slide, introduction to IR spectroscopy. IR spectroscopy is a powerful analytic technique used to identify molecular structure. It provides information about the vibration translation of a molecular bonds. The technique is widely used in various fields including chemistry, biology and material sciences. Next slide, fundamental principles of IR spectroscopy. IR spectroscopy is based on the absorption of infrared light by molecules. Molecules undergo vibrational motions which can be excited by a specific wavelength of IR radiation. The resulting absorption spectrum provides a fingerprint of the molecular structure. Next slide. Types of IR spectroscopy. There are two main types of IR spectroscopy: transmission and reflectancy. Transmission IR spectroscopy measures the amount of light passing through a sample. Reflectance IR spectroscopy measures the light reflected off of the surface of a slide. Next slide. Infrared spectroscopy is a chemical analysis technique that measures how a sample absorbs infrared light. It is used in many areas including food science to identify organic compounds and detect industrial pollutants. How it works: IR spectroscopy measures how molecules vibrate and rotate when they interact with infrared light. The energy of infrared light can be absorbed by the vibrational and rotations of molecules. Next slide. Sample preparation of techniques. Proper sample preparation is circular for obtaining reliable IR spectra. Common techniques include the use of a tin film, lanterns and solution samples. Each method requires specific handling and a condition to optimize spectra quantity. Next slide. Solid sample preparation. Solid samples can be prepared as a KBr fillet for analysis. The sample is finally powdered and moved with potassium bromide to create a transparent disc. This method allows for uniform distribution of the sample and a better interaction with the IR light. Next slide. Liquid sample preparation. Liquid sample are typically analyzed using liquid cells or tin films. The chance of a solvent is critical to avoid infrared in the IR spectrum. Converts made from IR transparent materials like quiz are commonly used for the purpose. Solid sample preparation is also used for the KBr fillet for analysis. It is used finely powdered and mixed with potassium bromide to create a transparent disc. Next, gas sample preparation is another side of IR spectroscopy. Gaseous samples require specialized gas cells for analysis. The path length of the gas cells must be adjusted to enhance sensitivity. This method is essential for analyzing voltage compounds and atmospheric gases. Next slide. Instrument in IR spectroscopy used. Modern IR spectroscopy utilizes Fourier transformation technology for a rapid data acquisition. These instruments provide high resolution spectra and improved signal to noise ratios. Continuous advancement in IR spectroscopy have enhanced with sensitive and accuracy in measurements. Another slide. Applications in organic chemistry. IR spectroscopy is widely used to identify functional groups in organic compounds. It helps to confirm the structure of unsynthesized compounds during research. This technique is essential for purity testing and quality control in the pharmaceutical industry. Next slide. Applications in environment analysis. IR spectroscopy is employed to detect pollutants and monitor air quality. It can identify specific chemical pieces in a complex mixture such as greenhouse gases, CH3 methyl and CO, etc. These applications are critical for environmental compliance and regulating monitoring. Next slide. Gas sample preparation in IR spectroscopy. The path length of the gas cell must be adjusted to enhance sensitivity. This method is essential for analyzing voltage and compounds and atmospheric gases. Next slide, applications in a material science. In material science, IR spectroscopy evaluates polymers and composite materials. It aids in understanding the properties and behaviors of a material under different conditions. The technique can also assist in failure analysis and material characteristics. Next, advantages of IR spectroscopy is rapid and can be used in many different settings. Disadvantages. One disadvantage of IR spectroscopy is that it includes to identify the chemical compounds detected. Next, future trends and development. The future of IR spectroscopy includes advancement in protoball and field dipole system. Integration with the other analytic techniques enhance the comprehensiveness of a molecular analysis. Ongoing search aims to improve resolution, sensitive and data interpretation capabilities.